Welcome back, students. Now, in the previous chapter, we learned about function and graph. So we learned about how to find the domain and range of functions. We learned about composite functions. We also learned about their inverse function. So at the end, we also learned about how to actually find the uh, graph of the function. Right. So for this chapter 2, we are going to learn another function called exponential function. Right. So these are the objective of the chapters. So make sure you come back to check this right after you have completed the chapter. Right. First, define and relate the concept of exponent. So we want to know what is called exponent. Right. Again, we will learn how to determine the domain and the range of exponent function. So we will learn how to develop and use the properties of exponential function. And of course, lastly, we will solve the exponential equation. Okay, so let's start with the concept with a story. Now, this story actually was an ancient Indian story. So then there was once a king, right, in India. He was a big fan of chess, and he has the habit to challenge a wise visitor to a game of chess. So then one day, there was this traveling sage, so was challenged by the king, right? To motivate his opponent, the king actually offered any reward that the sage could name. So, what did the sage? What did the sage requested? The sage requested, right, to give a few grains of rice in the following manner. Right, the king was to put a single grain of rice on the first chess square and double it on every consequent one. So the king actually accept the sage request. Now then, the king finally lost the game. So and then he ordered a bag of rice to be brought to the chessboard, and he started to place one grain to the chess the square, right? So he put one grain on the first square, two on the second, fourth, four on the third, eight on the fourth, and so on. Now, the question is, how many grain of rice does the king have to give away? Okay, now if we refer to the chessboard here, all right, the first square, one grain, then double, right, two grains, four, eight, and so on. Now, if we continue, we can see here, all right, up to here is already 1 million. Okay, so now on the 20th square is already 1 million grains of rice here. And the 40th square is already 1 billion. Okay, 1 billion grains of rice. Okay, so this is 1 million here. All right, and all right, on the 40th square is already 1 billion. Now, to reach the 64th square is actually, all right, I don't know how to pronounce this one, right, is about 210 billion tons. Okay, so this grains actually is more than whatever the country have during that time. Okay, so in this case, the kings did not able to pay the sage for the grains. Right now, when we see here, right, this is actually the concept of exponent. All right, so we double, right, double the quantity of the previous one. So when 2 to the power of 0, and we have 2 to the power of 0, which is 1. Okay, 2 to the power of 1 is actually 2, and 2 to the power of 2 is 4, 2 to the power of 3 is 8, and so on. All right, so of course in this case we are looking at 2 to the power of 63. Why 63? Because it started with 0. Okay, so each each calculation here double the quantity before it. Okay, now so this is called exponential functions. Now we call this is the base. All right, and the variable here is the exponent. Okay, so this one is called the exponent. All right, and the x here is the variable. All right, the a can be any value, right, more than 0, but the a cannot be 1. Okay, so now if we plot the graph, we can see the graph is actually goes like this. Okay, when we have, okay, let's say this is 2 to the power of 0, right, we have actually here, okay, which is 1. And when 2 to the power of 1, okay, we have 2, and so on. Right, the domain, now what are the possible value of x? You can see here that x can be any value. So for the domain, the x is belongs to real number. Now how about range? Now we can see the y is actually more than 0, and this is the asymptote, right? The y will not touch, okay, the x-axis. Therefore, right, we say the range, for the range, the y must be more than 0. Okay, this one we can put y, right? And y is a real number. Okay, now these are the example of exponential function. Now if we have 2 to the power of x, so we say the base is 2, right? The x is the exponent, right? The y equals to 3 to the power of x, the base is 3. How about this one? Y equals to 1 over 2 to the power of x. What is the base? Okay, so the base is actually 1 over 2. Now, however, we can actually change this one to 2 to the power of negative 1, right? All right, so, and if we change this to 2 to the power of negative 1, it will be 2 to the power of negative x. Okay. Now, let's look at the graph of exponential function. So if we have the exponential function y equals to 2 to the power of x, so this will be the graph. All right, so we can actually plot the graph by using the values here. When the x is negative 2, so substitute into the x, we have 1 over 4, all right, which is here, 1 over 4. And when the x is negative 1, right, the negative 1 is here, all right, the x is 1 over 2. When the x is 0, right, 2 to the power of 0, the y is 1. Okay, when the x is 1, the y is 2, and then when the x is 2, the y is 4, and so on. Okay, so this would be the graph. Now, if we plot y equals to 3 to the power of x together with 2 to the power of x, right? So we can see the graph actually goes like this. All right, so now at this point, when the x is 0, 2 to the power of 0 is equal to 3 to the power of 0, which is 1. Okay, so the two graphs intersect at this point. And for positive of x, all right, when the x is positive, all right, the value of 3 to the power of x is greater than the value of 2 to the power of x. Okay, so on the positive side, 3 to the power of x is greater than 2 to the power of x. However, on the left-hand side, when the x is negative, right, when the x is a negative value, now we can see here actually 2 to the power of x is greater than 3 to the power of x. Okay, so this is the graph of exponential function. Now, how about y equals to 1 over 2 to the power of x? Now, we can actually change this one to 2 to the power of negative x. So when we plot the graph, all right, it will be the opposite side. All right, so this 2 to the power of negative x is the symmetry on it's a symmetry with 2 to the power of x. Okay, you can see here this line is symmetry with 2 to the power of x. So then the graph goes like this. Okay, so again the domain, right, is x belongs to real number, and for range the y belongs to real number, and the y should more than 0. Now next we are going to learn about the natural exponential function. Okay, first, now this is called exponential constant. Now there are many constants in mathematics. For example, this is another constant. Right, what do we call this? We call this pi, right? Right, call this pi. And what is the value? It's 3.142 something. Okay, so the pi is a constant in mathematical constant. Now we are going to learn another constant called exponential constant. So the symbol we use is E. Okay, so the value, all right, approximately is this, all right, 2.71828 and so on. So usually we will assume that is, all right, 2.71828. Now you can use calculator, all right, when you have calculation involve the E, all right, and E is irrational, means that we cannot change the E to a fraction, okay? So why do we need this exponential constant? Because the natural exponential function is frequently encountered in various fields where mathematical is applied. So you will find the calculation in biology, all right, and in physics, right, in especially when the calculation involve some nature. Okay. Now, well, when we talk about natural exponential function and the graph, okay, we know that this one, okay, this is y equals to 2 to the power of x. And the blue color one here is y equals to 3 to the power of x. Okay, now this e is actually 2.71828, right? So it's between E is actually between 2 to 3. So the graph is actually here. Okay, so this one, the yellow color one, all right, represent the graph e to the power of x. So what is the domain? Again, the domain x belongs to real number. Okay, and how about the range? All right, for the range, the y all right, belongs to real number, the y should be more than 0, right? Now, please note that the 0 is not included. Okay, now let's see one example on the natural exponential function. Now, cholera. So this is a type of disease, right? Intestinal disease is caused by cholera bacterium that multiplies exponentially by cell division has given approximately by this formula. Okay, so this formula is to calculate the cholera bacteria. All right, so the n refer to the number of bacteria. All right, n naught refer to the number of bacteria present at the start. Okay, so this one is the bacteria at the start. Okay, and the t refer to the time, all right, after t hours. Okay, so now let's say, all right, in the beginning there was 25 bacteria. Okay, now how many bacteria are there? All right, will be presented, okay, in 0.6 hours later. Okay, to find the number of bacteria after 0.6 hours, so first, all right, we put, okay, 25 is the n naught, so this is 25. All right, so we have e to the power of 1.386, the t is 0.6. So solve this calculation using calculator, we will have 57.425. So it's about 57 bacteria after 0.6 hours. Okay, 0.6 hours. How many minutes later for 0.6 hours? Right, 60 minutes. So this is about 36 minutes, right? Right, so after 36 minutes, right, this is the number of bacteria. Now after 3.5 hours, so we can see here, all right, okay, we substitute 3.5 into the t, all right, it's 3196.7. All right, so it's about, okay, 3196 bacteria. All right, so this example actually shows us how to use the natural exponential functions in some biological calculation. Okay, now let's see another example. Okay, example 2, sketch the graph for which the following exponential functions and determine its range. Okay, now we have a function f 1 plus ex. Okay, now how to solve this, how to sketch a graph? Now we are going to start with the exponential function. So this is the x-axis, this is the y-axis. Okay, now for exponential function ex, all right, we know actually the graph goes like this. Okay, so on. Okay, the graph goes like this: y to the power of e to the power of x. Y equals to e to the power of x. Okay, so all right. Now, what is the value here? When the x is 0, e to the power of 0 is also 1. So the value here is 1. Now, what happens if the function plus 1? Okay, we know that we actually move the graph 1 unit up, right? So if we move the graph 1 unit up, then we will have the graph like this. Okay, so what is the value here? 1 plus 1, 2. Okay, we move 1 unit up, right, because of this plus 1. Okay, so this is the graph of y equals to 1 plus e to the power of x. Okay, right, so now we can see the solution, something like this. Okay, so what is the range? Now the range will be, all right, so since we move one unit up, so this will be the asymptote. And from here, we know that the y belongs to real number. The y is greater than 1. Okay, now how about the second questions here? Now the second questions, all right, so we use the same method. So first we are going to draw the graph. Okay, so this is y equals to e to the power of x. Okay, now after that, we try to find the e to the power of negative x. Now, do you still remember in this previous discussion, we talked about negative? Okay, let's scroll up a bit here. Now, when we talk about the negative, you can see here when it's negative, it's on the other side, the left-hand side, right? So this is 2 to the power of x, 2 to the power of negative x. Okay, so this is negative x. So we are on the left-hand side. So using the same concept, so for this one, when we have a negative x, so the graph actually goes like this. Okay, so this is y equals to e to the power of negative x. Okay, y equals to e to the power of negative x. Okay, and the answer here is still 1. Okay, so this intercept is 1. Now, what about this graph multiply with 2? So when the graph multiply with 2, all right, the effect, okay, now it's not very clear here, but we know that if we times 2, it will go steeper. Okay, so the graph will go like this. Okay, now it's not like this, eh? All right, there's a bit. So when we times 2, the graph will go like this. Okay, so what happened to this one? This is 1 times 2, it becomes 2 here. Okay, so it becomes a 2 here. Okay, so we have a 2 here. Now, how about minus 3? Now, in the previous discussion, right, we know that when we minus 3, we move the graph down for 3 units, right? Right, minus 3. Therefore, then we will get this one. Okay, so from 2 here, we move down 3 units, so we get negative 1. All right, so the graph goes like this. Okay, now make sure that the asymptote move together. So we have an asymptote here, negative 3, y equals to negative 3 here. All right, so this asymptote is used for us to find the range. Now, therefore, we know that the range will be the y must be more than negative 3. Okay, so to find this point, all right, we let the y equals to 0. So when the y equals to 0, we have 2e to the power of negative x minus 3 is 0. And e to the power of negative x is 3 over 2. All right, and bring the e over here, we actually have negative x is ln 3 over 2. And therefore, what is the x? The x is actually negative ln 3 over 2. Now you can actually find the answer. If you want to find the value, you can use a calculator to find the answer here. Alright, now next we are going to talk about the law of exponents. So these are the law of exponents. Okay, now if we multiply the exponents with the same base, so we have a to the power of m multiply a to the power of n, right? What can we do? We just sum the exponent. Okay, so it would be like this: 2 to the power of 3 multiply 2 to the power of 4. We just sum the exponent, so we get 7. So if we divide, all right, a to the power of m divided by a to the power of n, so we minus the exponent. All right, so for example, right, we can just take 4 minus 3 and we get 2 to the power of 1. Okay, so if we have a to the power of m bracket to the power of n, so we have a the power of the exponent. So what we can do is we multiply the exponent. Okay, the m multiply the n. All right, so for example, we can have 2 times 4, 8, or we can also exchange the position. The m and the n, we exchange the position. We exchange 2 and 4 here. Now the negative exponent is says that it actually is a fraction, is 1 over a to the power of n. So if we have 3 to the power of negative 2, it's actually 1 over 3 to the power of 2, which is 1 over 9. And if the exponent is a fraction, so the denominator here suggests that it is a root. Okay, the denominator represents the root. So if it's something like this, it shows that it's a root 3. Okay, root 3. All right, so we get 2. Now, the m here actually is the power. All right, the root. All right, the n is the root. The m is actually the power. So if we have 4 to the power of 3 over 2, so it's actually 4 to the power of 3 to the root of 2. Okay, so we can have 4 square root, which is 2, 2 to the power of 3, which is 8. Okay, number 7, right? If we have a times b to the power of n, we can actually distribute the n into the a and b. All right, so usually when we have 2x bracket square, so it will be 2 square, which is 4, and multiply with x squared. So if we have a over b to the power of n, all right, this will be a to the power of n over b to the power of n. Okay, so these are the law of exponents, exponential law that we frequently used in calculation. Now let's see some of the example here. Now if we're solving the exponential equation, all right, so there are 2 approaches. Now the first one, okay, what we do here is we compare the base. So we can see that the base is the same. All right, when the base is the same, so and they are equal, so it means that 2 minus 3x is also equals to 5x minus 6, right? So from here, then we can find the x. Okay, so the x is 1. Okay, now the other approach is, right, if the base is not equal, but the exponent is equal, so we can also compare and we say that 5 is equals to x plus 2. And from here we can find the x. Okay, now let's solve this example 3 using the 2 approaches we discussed just now. All right, now first we have 8 to the power of x equals to 32. Okay, now how to solve this? Right, first we try to equal the base, make the base equal, or we try to make the exponent equal. Right, now from here, we actually can know, we know that actually 8 is 2 to the power of 3. And 32 is actually 2 to the power of 5. Right? So in this case, right, we will have 3x, 2 to the power of 3x equals to 2 to the power of 5. Now, since the exponents is the same, therefore, by comparing, we know that 3x is 5 and the x is 5 over 3. Okay? So, this question B. Right, we have 2 to the power of 2x minus 5 times 2x plus 4 equals to 0. Okay, so now to solve these questions, first we can see here we have a 2 to the power of x here. So we are going to change this one to 2 to the power of x. So what happened to the 2? The 2 actually changed position outside. Okay, we put the position outside. So minus 5 2 to the power of x plus 4 is 0. Okay, now from here, now let's say we let the u be 2 to the power of x. So we can actually rewrite the equation as, so this is u, all right, this is also u. We have u square minus 5u plus 4 is equals to 0. Now, we can see here, now we have a quadratic equation. So we can factorize the quadratic equation. We have u, 4, 1, negative, negative. All right, and all right, now we have u minus 1 equals to 0. The u is 1. Now we change the u back to 2 to the power of x. Okay, now what is 1? 1 is actually 2 to the power of 0, right? Then we know that the x is 0. Okay, so on the other side, we have u minus 4 is 0. The u is 4. 2 to the power of x is, now 4 is actually 2 to the power of 2. So then we know that the x is 2. Okay, so therefore the x is 0 and 2. Okay, so to solve question B, right, we actually first we rewrite it as 2 to the power of x as the equation with 2 to the power of x. Then right, we solve the quadratic, right, and after that we find the value of x. Okay, for question C, okay, we have 9 to the power of x plus 1 minus 3x plus 3 minus 3x plus 3 equals to 0. Okay, now to solve these questions, question C, we try to change the base to the same base. So we can actually change to 3 to the power of 2. Okay, x. And plus 1 is actually multiply. So with multiply, so this is actually 9. Right? So, okay. According to the formula, it will be 9x multiply 9, 1. Okay, so 9 to the power of x, we change to 3 square to the power of x. Okay, and for that one, we have 3 to the power of x. So this is actually 3 to the power of 3, which is actually 27. Okay, so minus 3x plus 3 is equal to 0. Now, for the first one, we can actually change the position. It will be 3x to the power of 2. All right, 9, we put it in front. minus 27, 3 to the power of x, okay, minus 3 to the power of x plus 3 equals to 0. Now we can see we can actually solve this one. So we have 9, 3 to the power of x squared minus 27 minus 1. Okay, minus 27 minus 1, so we minus 28. Okay, plus 3. Now again, from here, we let the u be 3 to the power of x. So we have 9u squared minus 28u plus 3 is 0. And we can now factorize this. Okay, so we have 9u equals to 1. U equals to 1 over 9. 3 to the power of x is 3 to the power of negative 2. And the x is negative 2. And here we have u equals to 3. So 3 to the power of x is 3 to the power of 1. And the x is 1. Right, therefore, we have the x is negative 2 and